On this episode of the podcast, I have with me Keenan Wyrobek. He is co-founder and CTO of Zipline. We're going to be talking about the unique background of managing hardware and software, that intersection, but also it's a very mission critical product. And I'd like to kind of understand the challenges, the solutions, the design choices along the way. I'm sure building a team with a product like this is definitely got its challenges. So excited to have Keenan on to talk to us. So appreciate it. Thank you, Keenan.
Yeah, absolutely, Amir. Great to be speaking with you. I was immediately drawn to your resume, engineer turned recruiter. I think the thing we don't talk about is, the real job of a founder is an engineer who has to turn into a recruiter. So not to downplay like amazing recruiting partners who now work, with me and support our teams in huge ways. Still, half my time is in recruiting and really finding the amazing people required to actually pull something like this off.
Yeah, that could be a whole episode as to what my logic was to get into it. But actually, it was that I think actually the talent side, especially when it comes to a lot of the engineering leaders I talk to, it's about a third of their time, and we'll kind of dive in and talk a little bit about that. And before we do, to make sure we set context for everyone, obviously you're co-founder CTO, so I'm sure people know what you do. I'd like everyone to kind of understand what Zipline does as a product, because I think a lot of what we're going to be talking about in the context of the conversation kind of revolves around this unique, product and what's gone into it, and kind of, I love the mission behind it, honestly. So I'd love to kind of touch on some of those things before we dive into some of those team building challenges and some of the engineering leadership things you're doing there.
Yeah, sounds good. I mean, the quick overview is, Zipline's a drone delivery company, and we started in medical supplies, and now we're taking that same value of on-demand delivery, and we call it instant delivery, to revolutionize both goods delivery as well as good food delivery. This is what we do. We started in Africa. We're now in 7 countries. My favorite stat about our scale today is that we fly the equivalent of between 3 and 4 times the equator of the Earth every single day in operations. And sort of in a nutshell, that's what we do. Now, we started with this platform. If you've seen our website, I highly recommend you check it out. But basically, it's a fixed-wing platform. It looks like a large RC plane. It's great for going from a metro area and serving the surrounding, cities and countryside. And it delivers by flying over a delivery site and then dropping a package. It looks like a cake box with a little paper parachute that then floats down into your to your hospital, clinic, or home. Anyway, and then we announced back in March, which I've spent a huge amount of time on the last 3+ years, is this new platform, which is really answering our customers' requests for, hey, can you deliver to more homes and in metro areas? Which, as you can imagine, when you're floating a package down, it takes a little bit of space, a couple parking spots worth of space to deliver into. And most homes, and certainly in metro areas, you don't have that space. And this new platform basically is phenomenally precise, so it can deliver to nearly any address in a metro area outside of like the really tall high rise. And it can do it, just like our current platform, incredibly quietly and in a way that just is delightful. So, yeah, that's sort of Zipline and our basically product mix in a nutshell.
It sounds so easy that just kind of hovers down and drops down. And I mean, I think I've had some people from some autonomous vehicle companies on, and we've talked about their complexity. I think when I'm thinking about drones and delivering, talking about delivering medicine to Africa, to remote areas, let alone homes, there's got to be a lot that goes into ensuring safety, accuracy, dependability, reliability. There's some FAA private compliance, which I don't even know. I'm just guessing at this point, but I'm assuming you're flying something in the air. So it seems like it's a massive intersection of hardware and software. But then obviously the mission and the value that's being delivered is obviously really high, and that's something obviously people are asking for. When you're kind of looking at the product, and obviously if you're taking a second to look back as to where you started and kind of where you're at now, did you first, when you started thinking, hey, this product, we're going to do this, that mission, and where you're at now, was that something that you were like, you know what, we're going to try this, we're going to see if we can do it? Or was there like, hey, we're going to go through every barrier no matter what, we're going to make this product functional, we're going to make it work?
Yeah, I mean, for me, I did something at Zipline that I haven't actually done in any other thing I've started, and which is really to, before doing any tech development, really get out and really meet real potential customers and spend a lot of time with them. And to be clear, did that for a whole bunch of potential products that did not become Zipline. There were other things until finding both who became my co-founders, as well as this particular application. Spent a bunch of time in Central America and Africa based on the suggestion of family and friends who were like, hey, we hear about these health campaigns that get stuck on logistics. Can you go, maybe, at the time Amazon announced drones for delivery, maybe drones can be the solution here. Now, to be clear, on these trips, I fully expected to go out and learn a ton about this and find a million reasons why drones would never actually be the solution. Because I don't know, I guess I'm inherently skeptical, and I think one of my superpowers is I'm not an early adopter. Like I want my tech to just frickin' work. So I always I'm not willing to put up with stuff that doesn't work well, which is great when you're making products for customers beyond the early adopters. Anyway, and so in these travels, it was as we got deeper and deeper in this world of healthcare logistics, got to know more people, understood the magnitude of the problem, but also that there were supplies available and the demand was there. And really it was I remember visiting this was a warehouse in a country I probably shouldn't name, but we were getting this tour of this medical supply warehouse, and we're outside the warehouse, and there are boxes like maybe 2 stories high and like 2 football fields worth of these boxes just outside. And I was talking to the person walking next to me, like, hey, what's the deal with these medical supplies outside? Why aren't they inside the warehouse? Didn't get an answer. A little bit weird, a little cagey. Anyway, after the tour, as I was saying goodbye, this person pulled me aside and he was like, we're not supposed to talk about this, but that's all expired medicine. That's why it's outside. And it was kind of like, it was one of those moments, it was part of that journey of like, whoa, okay, if we can get these supplies from point A to point B, we can actually have a massive impact. And so for me, like that was a bit flip. We had real customers who I deeply understood, and I had the conviction from that understanding of like, yeah, there's a solution here. And then for me, it's kind of a bit flip in my head of like, okay, I'm no longer in like, why shouldn't we do this? And now it's like, all right, we got to figure out how to do it. And yeah, everything about the journey that came next was harder than expected, but it's working. So
yeah, absolutely. I mean, that's pretty compelling. Obviously, it kind of must have pulled on your heartstrings. That then again, the mission of the company and everything you've done kind of stems from what you just described. I guess I was kind of curious as you kind of stood there looking at these boxes, these expired medicines. The flip in your mind, you're like, hey, why not? How can I? Do you start piecing together, like in your mind? Are you trying to map through the various pieces that go in here? You're probably thinking, well, something's got to potentially get it there. We need the accuracy of the software. I mean, obviously, you have a background in robotics. How does your mind start running through that? Because obviously, now you've moved to, hey, I'd like to solve this problem. Is it a hardware and software problem, or were you focused on, hey, maybe it's going to be one or the other? What were your thoughts originally?
I mean, that's a great question. Wow, going back in time a little bit. So I'm definitely a to-do list person. I immediately start writing out like what would it take to build this system? Like, what are all the pieces? What are the hard parts? From that, like there's a million questions of like, oh, I got to go learn more about this part of what, how the customer operation works and this part of how X and Y works. And so a lot of that sparks going deeper with the customers to really understand more. But right off the bat, there was kind of two things that were really clear. For this platform one, this long range platform, it was really clear the 2 things that mattered. We needed to have very low cost per delivery, and we needed to fly as far as possible. And it was like, all right, well, hey, that the only way, if you probably like a lot of the drones that you picture with the hover rotors and stuff like that, they're not very efficient flyers. So it was like, all right, is there a way to do this with a fixed wing vehicle that is really freaking efficient? Basically, this is going to get you that low cost at unbelievably great range. Is there a way to deliver that will actually work? And like immediately it was like making prototypes of packages and hucking them over the fences of these clinics around the world and trying to watch the doctor's reaction for like, were they like cool or like, absolutely not. And to be clear, early prototypes of that, they were absolutely not was their reaction. We eventually figured out, what was required there. So there's a lot of that. And then there's just a lot of learning too. The other big assumption I had there was like, cool, somebody must make a drone I can just go buy, modify with a little package delivery thing on its belly and start serving a customer and learn more about this. And to be clear, that was a terrible assumption. Talked to many companies building drones. And I still remember the best quote I ever got was a drone for $200,000 per drone with a 200 flight warranty if I did not fly it in the rain. And to be clear, our customers, we fly in the rain almost every day. and 200,000 divided by $200, the economics don't work even a little bit. And that was a bit of one of those bumps in the road where, it's like, all right, hey, there's a way to get started here really lean. And then the reality was like, nope, we're going to have to do this. We're going to have to do more of this ourselves than we expected. And that's been a journey across the board. I think that if you had told me back then we'd be doing our own weather forecasting, which we do today, I would have been like, wow, why would we do that? I'm sure someone can sell us the right weather forecasting at the right time. But that's just one of the many pieces of the puzzle we've had to mature over the years to enable this kind of scale, this kind of safety and reliability.
Maybe this is the wrong analogy, but maybe you can correct me. But it almost seems as though you're like a little mini Boeing. Like obviously they make 7X jets, the 737, the Max one, whatever they want. It almost sounds like you are like a miniature version of that, but building these last mile drones. I'm sorry if I'm calling it the wrong thing, that have all these tolerances that can still go a long distance. You just mentioned you have to deal with the weather, and obviously you have to worry about the plane itself. I mean, this little drone that you guys have made to fly safely, come back. Am I wrong, or I'm just because I'm trying to put in context it seems a lot more complex, even just when we were talking about it 2 seconds ago. You mentioned weather. I'm like, wow, this is a lot more to it than just, hey, let's figure out this drone thing.
Oh, absolutely. I think there's, from a team skill set point of view, we have a lot of Boeing DNA at Zipline. But we also have a lot of other company DNA, a lot from where I started my career in medical robotics and places like Tesla and SpaceX. And I think a lot of it is basically, you have to achieve the same things that people like Boeing achieve, right? Like, we fly over people and we got to do that safely, right? And if we're not doing that safely and people don't trust us, just like they would trust a Boeing, like we're not going to get to do this. Not to mention we wouldn't be taking our sort of ethical responsibility properly. Yeah. At the same time, this is an autonomous system, and from the ground up. And so, that's not something in Boeing's DNA. And, rethinking how do you write software? How do you validate and make sure your software is reliable? It's something that we've done that no one else has done, right? I don't know of any other company that's releasing safe critical software, on a basically near monthly basis, for any kind of scaled autonomy system. Well, there really aren't. As far as I know, we're still the largest scale autonomy system in the world. But anyway, we had to sort of invent. How do you think about that? How do you think about the testing and the automation around that testing so that you maintain your flexibility for innovation while being responsible and operating safely? And so there's a lot of pieces where you kind of have to go back to first principles. There's a lot of where the hiring comes in, is like finding people who love taking where they've been and rather than copying what they've done before from a process or mindset point of view, distill it to first principles and reapply it to this very new challenge is a big part of what we spend all the time doing. Because basically once you crack that nut, then you can actually make something like this work.
Maybe let's actually jump to that. Obviously, I want to talk about balancing engineering and hardware and software engineering hardware. But I'm kind of curious. You mentioned the hiring piece. So if you go to the website, you'll see some example of the technology. You'll see a little picture of a package gently floating back to Earth. And I'm looking and thinking it seems very complicated. I don't even understand how you guys measure trajectory, wind speed, speed of drops, where it lands, the radius. And you just mentioned, obviously, SpaceX, Boeing, a lot of these companies that have done similar. This seems kind of unique. And you mentioned hiring for people that are going to be able to actually kind of push past current limitations, current ways things are done. When you're looking for those people, and obviously we're going back because the original 20, 40, 50, 60, you need some of that power to kind of come through to that baseline. I mean, how do you evaluate if someone has that characteristic? That is, what you're doing is a little bit even harder than somebody just hiring a DevOps engineer to come in to do something that hasn't been done frequently. But this is a whole different ballgame.
I mean, there's a bunch of interview strategies for this. So my favorite one is basically one thing I'll do with almost everybody is basically I'm going to ask them to take me through a design that they've done and go deep, right? Like really teach me something I don't know about in terms of the physics of it or some aspects of the engineering of it, or maybe the testing of it, whatever's like really hard and something, turn it into a class, like, hey, this is for me. And so I want to see how deep that they went in that problem. And then after that, basically I ask the question of like, okay, what are your fundamental takeaways that you imagine sort of applying to any future project you do? And I ask them to kind of apply that to sort of what they imagine the challenges at Zipline to be. And the people who are good at that process of taking their experience, distilling it down to kind of the first principles that can be reapplied in really smart ways, those conversations are so much fun. I learned so much about how to think about the problem, how they will contribute, how they would lend diversity to our thinking about the challenging problems at hand. And I think that like that's my favorite way to do it. There's that's obviously there's other techniques too. Looking at your resume is a big piece of it. Like have they successfully done a series of weird things that are weird, right? As opposed to like done the same thing over and over in their career. That's a good sign that they're wired for this. Those are probably my two favorite indicators of this kind of thing. To really get that conviction that,
Absolutely. I guess as you're kind of building the product, I mean, this could be, previous, current, future. I mean, you guys probably go through different design options, choices, alternatives. There is some trial and error as you're going through invention of anything. As a leader, when you're going through that process and you're observing someone try different things, obviously you want to give them enough room to try, go through that trial and error, but also then you have to have a point of going, we just aren't finding the right thing. Is that person the right fit? That's a lot more art than science, maybe, or maybe there's more science than I know. But how do you evaluate that? Because this is kind of tricky given what you guys do.
Ooh, yeah, you're asking the hard questions. Okay, I like this. There's a couple different pieces. Let me start with a little bit of our process. So when we're tackling something new, so our Platform 2 system, this is the precision delivery that was going through a big testing campaign now. That solution I should mention. So this is a vertical takeoff and landing system. So it has hover rotors, and it lowers down this thing we call the droid on a tether down to the ground to drop the package off and then retract and get out of there, which makes the delivery silent and super precise because that droid is actually actively controlling itself, and against gusts of winds and things. And then it also radically simplifies the safety. So when we started the development of this new platform in I guess it was about 2020, early 2020, we started with a really small team, like literally just a couple folks. These were people that are wired for this kind of work, right? They have. You mentioned there's this common, when you're doing the. So big picture. We think of phases, right? So conceptual phase, alpha phase, and detail design phase. Conceptual phase is figure out the product. What is the product? And addressing all the core product risks. Alpha phase is really like get the architecture right, and then detail is like actually design the production intent parts and whatnot to actually take it to manufacture to production. That first phase is really, really tricky because you're spending a lot of time with customers. You're going deep with customers, and we have a saying in Zipline: you don't listen to your customers, you understand them. In a design process like that's an important distinction. It's very easy for customers to like tell you some things and whatnot, but like it's critically important that core design team in that conceptual phase, they deeply understand their customer. They can complete their customer sentences how they think about it if they understand them deeply enough. That's how much time they've spent at their sites, getting to know them, building the relationships, going deep with the customers on data, with the customers' data to really understand what's going on in their world. And then of course that team is iterating like crazy, and it is like most of like all the gates here. The gates when you're exiting conceptual, it's not a schedule-driven gate. It is the way we talk about it internal to this team is like we have to have confidence that we should bet the company on it, and then we have to pull together enough of a prototype and all the economics and basically address all the key risks so that when we turn around to the company and say, hey, company, all the leaders in the company and the board and the company itself, we think we should bet the company on this, and here's why. That's going to go really well. That's our exit criteria for conceptual. And as you can imagine, along that journey, you'd like that to go pretty fast, but you can't rush it because obviously, if you exit with something that's not actually something you bet the company on, well, it's a bad bet. So I find that phase, you need people who are really good at being obsessed with the customer and going deep. They need to be really capable of designing across the technologies that involved in the product. And so, and they have to have an inherent sense of urgency, because again, you can't put an arbitrary date to drive pace. They have to want to move fast and want to iterate fast, and have some sense of like how to get the most out of every hour and every day without needing like some kind of external timeline to create that urgency. And so, yeah, this is we call this the new products team at Zipline. This is a relatively unique set of folks who are able to do that kind of work. And it's a hard, and by the way, it's a hard skill set, but it's no harder than like the production intent design team. It's just very different, right? It's just kind of night and day, if you will, in terms of how the different people peak in those different phases. But yeah, so there's this is the journey where you're trying to figure out like, hey, you have a thesis of like, hey, our customers are asking for this. Let's go learn about that. Let's think about, can we address that? Is there a product there? Then of course, once we had conviction, and we had, for Platform 2, our customers have asking for years, hey, can you do home delivery at scale? Can you do home delivery in metros at scale? And our answer was always no. Like, we specialize in metro to the surrounding areas. That's just not what we do. But of course, when your customer asks you enough, you got to start going deeper in that and learning more about that. But at the same time, when we started looking into this, it was like, hey, is there even a product here we'd ever want to ship, right? Because we looked around at like sidewalk robots and other drone solutions and things like that, and they're generally not very precise. They don't deliver to everybody. They're very noisy and not something we actually think anybody would want at scale. We wouldn't want at scale. And other fundamental limitations. So like, all right, let's explore this. Let's go deep with the customers to understand this deeply, and let's see if there is a product here that we actually would want to ship. And that's just a lot of iteration, a lot of exploration, a lot of dead ends, a lot of things where you're like, hey, this is a good idea. You start prototyping it, and you're like, you bring it to life, you're kind of like, oof, yeah, don't like this direction. And either from a tech risk or more often than not, just from a human, customer experience point of view. I've worked on a lot of robots in my career, and it's very easy to make robots that most humans will not want to spend time around. And creating an automated thing that actually people want to be around and actually is, let alone is actually safe enough for people to be around. It's a challenging thing to come up with that architecture. And of course, it's easy. It's got to be a great product technical architecture that is also going to work for the customer and the business economically, which is,
I guess, yeah, as you're going through these design choices, you have a hardware component that you might be testing, and has its own complexities, because obviously, as we've talked about, you guys have to even know about the weather and the tolerances of of an airplane. You have a lot to go in there, and then you have the software component. As we've learned through the news the last couple of years, software within flying and airplanes is not easy to get. We've seen big companies not do it well. When you are looking at both these mixing together, which is the chicken and the egg? Is it hey, let's work on the hardware, the software comes secondly? Is it parallel? Because it seems like maybe you need the hardware to figure out what the software is, or I don't know. What comes first?
It's very much in parallel, and it's sort of, you kind of want to break that chicken and egg cycle by saying, hey, what are the biggest risks to this product? They might be a technical risk, or some user experience thing, or some big schedule risk. You just don't know how hard it'll be to develop something. And oftentimes what makes that list is not hardware or software. It's both, right? It's a problem that is both. And a good example of that is the drone. We call it the Zip for Platform 2. It has to be able to fly and deliver in stormy weather, and it has to be able to do it if it has like a rotor out or something like this, which is a level of fault tolerance and robustness in what's called an eVTOL platform, to use that flying car term, that has never been shipped, that's never been achieved, right, in actual production product. And so it's like, well, that was one of these. We identified about 8 of these big risks that were cut across hardware and software. And we created a team specifically to work on that. It's a pretty small team that has the controls background, the software background, the prototyping, and the aero skills. And they literally worked sort of in their own little world, creating their own prototypes and doing their own iteration to basically work through the risks of that challenge, in parallel to these other 8, the other 7 of these 8 big risks. And that's really important, because if you tie a lot of these sort of hardware software worlds, they try to iterate kind of the hardware and software together, tied with one big integrated hardware thing. So they'll build like one giant proto and then work on some software, and then build another generation of the giant proto and work on some software. And so now you're limited by that full hardware proto coming together. And that slows everything down a ton, right? Like that world I just described around the vertical takeoff and landing and the transitioning from vertical takeoff to fixed wing flight. That team probably went through dozens of prototypes, iterations over a couple of years, which it would have been impossible for them to go that fast if they had been encumbered by the pace of what was needed by another big risk we were trying to burn down. And so I think this has been one of my I've spent my whole career in hardware plus software projects, and this is I think treating them as these focus on what the biggest risks and put the hardware software team together that can move the fastest to a great solution to address that risk always pays off. And once those are retired, is the word I love to use, once those risks, you're no longer worried about them anymore, basically, then it's okay, cool. Now we start bringing those folks into the broader team that's going to make the production intent unified hardware and software system. But in that early phase, you got to keep them separate. But again, not separate hardware versus software, risk versus risk.
How's the team set up? I guess you talked about this unit. Obviously, they might be together to solve certain problems. Are these product aligned teams? Are they matrix teams because of the unique skill sets that come into play?
So the new products team is a little bit of its own little oddity in Zipline. In the early phase of a product, they're leading it. There's a few other folks involved for prototype and other things, but we think of that as the startup in a startup phase of that, where they're literally everybody involved in that is not allowed to think about anything else at Zipline. They have to just focus on that. But then once you get to the end of conceptual phase, we call it the conviction milestone. It's like, hey, we're going to go for this thing. That's the point at which now the greater company is getting involved in the architecture work. And now those people that were, basically kind of focused and independent, now those people basically engage with all the engineering teams at Zipline to basically start working on the architecture. And that's what they call the alpha phase. And so Zipline, the greater engineering teams at Zipline are organized around basically core systems. So like powertrain, right? From battery to the motor design is one example of that group within the greater org. Another example is avionics, which is basically like the core compute and control, electronic control systems. Anyway, there's a handful of other teams and around these electromechanical hardware systems at the quote low level. So low level for us means low level software is like the embedded layer of the software. That's how those hardware or mechatronics teams are organized. And then separate from that, we have sort of controls and autonomy and these other teams that are a bit independent, if you will, in the org. But of course, they can't be very independent from a system perspective. And it's really important that during that alpha phase, there's a lot of working together. There's a lot of literal moving desks where it's like, cool, we need to answer this architectural question. Let's get these three folks from this team and these folks from this team to go deep and really iterate on the architecture for this subsystem and come up with the simplest possible thing. Yeah, and I love this question too about the how do you move forward? And this is at the alpha phase. We have a bunch of folks who are really good at architecture and have a really broad skill set and are good at coming up with the simplest possible solution. And I look a lot to them in the architectural process. Basically, I'm literally asking them, "Hey, do you believe this architecture you're working on is this a simple, elegant thing we're going to be proud of and love building on top of for the next couple of years?" And if the answer is no, we put the brakes on, back to the drawing board, keep iterating. And this is a really important thing because what we do at Zipline is incredibly complicated, right? So many systems, so much technology. It's incredibly important that every single piece of the puzzle is as simple as it can possibly be, right? And it's always cheaper and faster to put the brakes on at that architectural phase and keep iterating until it's as simple as possible and then go into detailed design than it is to kind of be like, let's just go into detailed design. It's good enough, right? It's always like a little bit of like, it's kind of like, complexity squared. Every bit of complexity you take out reduces the work ahead by a ton for a ton of teams, right? And so you spend a lot of time there. A good example is when we started architectural phase platform 2, our Zip had 6 rotors, right? And we figured out a way to go down to 5 rotors, and that's a perfect example of a holy grail. If you can remove that much complexity and moving parts and mass from an aircraft, like we just made our life so much easier going forward, and the teams came up with that kind of architectural simplification in that phase.
Interesting. I guess final question for you. A product like this where there is a lot of trial and error, there's a lot of, there's different phases, different complexity, lots of complexity. I guess it'd be easy sometimes to, if I'm working on a project and things aren't going well, to kind of maybe lose spirit, even though I'm for the mission. But how do you help ensure that level of motivation? People are, realizing that, yeah, we're going to make a mistake along the way, but that's okay. It's easy said, but then individual contributors, easy to also feel like they're letting the team down, not executing, not, pulling their weight. How do you do that?
There's a couple, I'd say two big things. We focus in the early phases in terms of like celebration on, basically our speed of learning, right? And so when someone had an idea, hey, I can prototype this and get some learnings in a week. Someone's like, hey, there's something we could do to get 9% of these learnings in a day. We celebrate that like crazy. And basically, there's all these designs. But when you at the end of the design, they look really brilliant. Like, oh, I can't think of anything better way to do this. But like, that's born of 999 sort of lessons learned quotes, right? Like basic mistakes along the way, dead ends you found or things you tried. But if you're focusing on that rate of learning, that's how you get to somewhere amazing. That those are people in leadership positions at Zipline are great at leading teams to learn fast and be really creative in how you learn. That's really important. The second big thing, though, is honestly kind of simple. It's really just connect the team to the customer, right? Like, and in the conceptual phase, that's easy because that's what the team is spending half their time with customers practically. We're just always talking about the customer, talking to the customer, on trips to visit the customer. And, I think great engineers and great designers, we just love to be like to do something for an actual human. That's the whole point. It's like, hey, if we can solve it for these people, that's what's really motivating. And by the way, I will say, this is another sort of interview thing we look for is, I don't hire engineers who just don't want to talk about the technology. We found that the most brilliant engineer who doesn't care about the customer and doesn't care about what you're doing for them, like in theory, they would still be great because they're just a brilliant engineer at something. But it turns out like what's more important than a brilliant engineer is the simplest possible solution for a customer. And if you care more about the customer, you'll be craving, hey, how do we ship this sooner? How do we make it simpler? How do we, how do we boil this down a little bit more? Yeah, so today we just announced Cleveland Clinic, and along the way, as these new health systems have joined Zipline or any customer, we love to invite their leadership to our all hands and to speak about why they're excited and how they're going to use Zipline to transform what they're doing for their patients and their customers. And so we're basically always looking for these ways to just keep everybody connected to what matters to our customers, both for motivation, but also because the only way we get this thing done, and the only way we ever ship product, is if people are just constantly obsessed with like, okay, what matters most to the customer? How do I simplify? People always joke with me if I walk into a room, like people now know me very well, so I can walk into a room where someone's debating some trade. If that debate is academic, they know what I'm going to say. It's like, shut up, get out, go understand what the customer needs, because every trade we make should be based on what matters to the customer. And if you're debating something academically, it means just stop that. Go learn more about the customer around this area and use that to make the trade. You can almost always do that. And you should. And it's a great litmus test of like, oh, okay, this team, we just need to like go spend more time understanding something about what matters to the customer and then use that to drive to that simpler solution. And then, of course, once you make decisions that way, then it's really fun to like go build the thing that you have confidence a customer will actually love using.
That's awesome. I'm gonna remember. I'm gonna remember a lot. I'm gonna take away a lot. But this end quote of "forget everything, go talk to the customer and make sure it works for them." I think that should be applied to every business. Obviously, you've got that down to science. Thanks for coming on. Thanks for sharing. A lot we could have gotten into. I feel like I got to be cognizant of your time. Let you get back to solving these amazing problems. If somebody does want to reach out to you, just to follow up on something you might have mentioned, what is a good way of maybe reaching out to you?
Yeah, absolutely. Yeah, hit me up on LinkedIn. Hit me up on LinkedIn, and send me your question when you connect with me or whatnot, and I'd be happy to answer questions. I learned a lot of things the hard way, but I've also learned a lot from great mentorship, and I'm always happy to pass it on. So
awesome. We'll make sure we include that. That's it for the episode. We'll be back again, different guests, different topic. Until then, two things. One, share this episode with somebody else who actually just wants to learn about hardware, software design, a cool mission. The product's really amazing. Share it with somebody else. I think you're going to hopefully enjoy this. I really did. Secondly, like, subscribe, leave a review if you can for the podcast. I appreciate it. Thank you. Until next time. Goodbye.